Okay, geometry, hopefully this video is going to work. There was a lot of buzzing in the last one, so I deleted it. Plus, it was 24 minutes long, so I'm hoping I can shorten this up now. So we have 7.3, use similar right triangles. So what we're going to be doing is taking a big right triangle, make an altitude, you have two smaller triangles, and they're all going to be similar. So I'll show you how that works. So first of all, a little bit of practice. You'll see why we're going to be doing this practice, but are these two triangles similar? Well, let's see here. Remember, all three angles need to add up to 180. So I'm going to take 180 and subtract these two angles, 80 and 70. Well, 80 plus 70 is 150. So when I take 180 minus 150, I'll get 30. Oh, and that's the other one. So they are similar by angle, angle. And whenever you are doing a similarity or a congruence, you should write down what that similarity or congruence statement is. So in this case, a similarity statement, I'm going to just go in this order. The triangles are drawn, so they're in the same format here. I have triangle EDF is similar to triangle BAC. All right, the next one, a little bit of Pythagorean theorem. Problem is, I did not put a right angle in there. Sorry about that. So find x. Here we go. X squared is equal to 14 squared plus 48 squared. So add the sum of your legs squared. So the sum of each leg is squared is equal to the hypotenuse squared. All right, 14 squared is 196. 48 squared is 2,304, 2304. Add that up, you're going to get 2,500, 2,500. Take the square root. Remember, when you take the square root, you get plus or minus, but since we're dealing with a distance, it's positive. The square root of 25 is 5. The square root of 100 is 10, so 50. Not bad, huh? All right, so this is a little activity that does take time, but I'm going to go ahead and work this out quickly. And I want you to just watch it. We will do this one in class. So take a piece of paper and draw a diagonal on the paper. So I did that already. I did put black around the edge of this paper so you can see it better on the video. Now I need to fold the paper to make an altitude to the hypotenuse of one of the triangles. So I'm going to take this corner and see how, you can see how I have the, I don't know if you can see this line, but I'm going to line it up along this line until I get that corner. And then I'm going to fill in this triangle. Use a straight edge here, just so you can see it better. All right, got that? Now, I'm going to label these corners as shown. This is the smallest angle of each triangle is going to be, first, the right angle, number 2, angle 3. So now let's look at this one. The smaller angle is right here. 4, the right angle, 5, 6, the smallest angle right here, 7, the right angle, 8, and then 9. So then we want you to cut it out, and we're going to have to rearrange them. I'll have to flip one side over. Let's cut this puppy out. I hear JD calling me. I wonder what he wants. Okay. And it says, arrange the triangle so angle 1, 4, and 7 are lined up. All right, so let's see here. I'm going to start with, I wanted to go backwards here. Where's angle 7? So here's angle 7. And then I need angle 4. So it's going to be like upside down. And then angle 1. I have to actually flip this one over. See how angle 1's right there? Angle 2 is the right angle, and then angle 3. And put this, I'm having a hard time here. Put this underneath, and what do you notice? Angle 1, 4, and 7 are all the same. Okay, it's sticking. I have my right angles. So basically they're all similar triangles. Why is this? There we go. It's a little bit better. It's going to look like this. So I have similar triangles by angle, angle. They all share this angle, and then I have a right angle. So that means you will be able to make ratios of sides. Okay, so we'll do that in class. All right, now you'll notice I have a lot already filled out on here. I'm going to do the same on yours. So I have a bit of coloring to do. Or maybe I'll do that. Actually, I think I'll just do that with you before you actually do the notes. So here we go. If an altitude is drawn, okay, that would be this line right here, to the hypotenuse of a right triangle, then the two triangles formed are similar to the original and to each other. So that means I drew the medium, then I drew the small, and then I have the whole thing. And that's really hard to see. Crazy green pen. It's actually a lime green. Okay, so I have the medium, small, whole. So basically, in these orders, the small is similar to the whole triangle. So the pink is similar to this whole green. The medium, which is blue, is similar to the whole thing. And the small is similar to the medium. So I showed you that with a little activity right before this. And the order matters. You got to be very careful. Always know that there's usually a short leg and a longer leg. So that's how I'm going to compare them. So example 1, identify the similar triangles in the diagram, sketch the similar triangles, and write the similarities. So what I did was I took the small triangle right here, put it right here, and I actually reflected it over. So it's SPQ, or sorry, QSP. Is similar to, now here's the medium triangle. I had to rotate it a little bit and flip it over. RSQ. I'm putting the right angle in the middle of each one of these. And then the whole triangle, the right is in the middle, that's Q. So the smaller angle, RQP. So I wrote them in this way so you can actually see which sides will correspond. Like this side will correspond to this one, which will correspond to that, etc. All the hypotenuse will correspond. All right. We're not going to do example 2 yet until I look at this geometric mean. So I know this looks like an absolute mess. Excuse us. I was printing on. I'm trying to get rid of paper here. This geometric mean formula, number 1, is basically comparing the small triangle to the whole triangle. Geometric mean formula 2 is comparing the medium to the whole. And geometric mean number 3 is comparing the small to the medium. All right. So basically what they've done here is, I mean, if you look at it, they have the left to the whole thing. AD over AB equals AB over AC. Notice when you cross multiply this, you have AB squared. This one, when you cross multiply, you get, this should be BC squared. And when you cross multiply, BD squared. So your geometric mean, you're always going to have a segment twice. So here we go. Using the small, which is this part, basically they compare the short leg of the small over the hypotenuse of the small to the short leg of the whole to the hypotenuse of the whole. Okay, so look at the small. The short leg is AD. The hypotenuse, so short leg to hypotenuse, the hypotenuse would be AB. Now look at the whole thing. The short leg is AB, hypotenuse is AC. So this is basically what helps me stay organized. Okay, now comparing the median to the whole, which they say is the right to the whole, the right side. So the right side compare the whole thing. When you're doing the medium, you're going to use the long leg compared to the hypotenuse. Okay, so the medium triangle we have, okay, so basically that's this right here. The longer leg is DC. The longer leg here is BC. So I have DC over BC. To the hypotenuse. The hypotenuse here is BC. Hypotenuse here is AC. So BC to AC. Tricky, I know. It's going to take a little bit. We will have to practice this. Now, when you compare the small to the medium, okay, they're going to go short leg to long leg. So first, short leg is AD, the long leg is BD. On the medium triangle, short leg is BD, long leg is DC. So that's how it's going to work. All right, so now let's go back to example 2. We want to find out how tall is the maximum height of the shed. So from here all the way to here. So that means I need to find this little part right here. Okay, so if you see what I have, we're going to compare the medium triangle, which is this side, to the whole thing. So that's going to be long leg to the hypotenuse. All right, so with the medium triangle, it's just this side. the long leg, let's see here, the long, yeah, this is our right angle for this side. The long leg is 15. The hypotenuse is 17. Oh, wait, I did the smaller side, I think. So the smaller side for the, wait, that's not right. I'm getting myself confused. All right, in any case, I have 15 over 17 is equal to x over 8. So I have a long leg over hypotenuse, and then x over 8. So I just don't have this drawn to scale, is apparently what I have. So when you cross multiply, you have 17x is equal to 15 times 8 is 120. Divide both sides by 17. X is about 7.06. But I need the height of this whole thing, so I have to add 9 to it. So add 9. You're going to get 16.06 feet. We'll probably have to go over that again. All right. Next page. Oh, we did that one. Okay. So using the geometric mean, find the value of k. So here I already have this. I got to fill this in. K is right here. This whole length is 16, and that little part is 7. You can see that. So since this is on the smaller triangle, I want to compare the short leg to the hypotenuse. So the short leg is 7, hypotenuse is k, and then compare to the whole. This whole thing, short leg is k, hypotenuse is 16. Cross multiply, k squared is equal to 112. K is the square root of 112. That's how you get rid of that square. That's the same as square root of 16 times 7. So 4 square root of 7 is the exact answer, but we are dealing with a story problem or like a distance. You should find the decimal. It's about 10.58. I don't know what the unit is, so I'm just going to write unit. All right. Some more geometric mean stuff. Okay, so the altitude formula versus the leg formula. And I know I've already given you this twice, and I'm going through it again, but the altitude formula is going to compare the small to the medium. So they're doing the short leg to the long leg. So the small is on this side. Okay, so the short leg is AD. The long leg is CD. And then on the medium, the short leg is, remember that's on top, is CD. And the long leg is BD. If you did it right, you'll notice when you cross multiply, two of the segments should be the same. Okay? And notice I split this in two because we have two leg theorems. First, let's compare the small to the whole, and that's always going to be short over hypotenuse. So the small is on this side. My shorter leg, we're just going to call AD. In this case, it says X. And the hypotenuse of that smaller one is AC. Now, for the whole triangle, the shorter leg is AC. Hypotenuse for the whole triangle is AB. And notice, once again, this should be squared. AC squared is equal to AD times AB. Going up here, if I cross multiply, CD squared is equal to AD times BD. And comparing the medium to the whole, so the medium is on this side compared to the whole triangle, it's going to be long leg compared to the hypotenuse. So the longer leg here is DB. Hypotenuse will be CB. Now for the whole triangle, the longer leg is CB, and the hypotenuse of the whole triangle is AB. And again, when you cross multiply, you have CB squared is equal to AB times DB. Or you can switch this around and say DB times AB. Your choice. I know, confusing, but we can do this. Hang in there. Here's a little method or another summary that I think some students actually like better. Okay, so you have the altitude rule and the two different leg rules. That's why there's two different formulas here. Let's see if I can get that better. All right, so watch this. The altitude rule. Take the altitude of your whole right triangle, h squared equals that little part times that little part when you split that whole hypotenuse. Now the leg rule is you have, let's see here, a squared is equal to, okay, a is on this side, y, which is on this side, times the whole thing. So a squared is equal to y times c. But then if you work with the smaller triangle, you have b squared equals to x times c. A lot of students like this method also, so I'll probably make a little poster of that and put that up in the room. And speaking of posters, I will get a copy of this for you, okay? So it kind of puts it all together. Hopefully it'll help you. So let's do a little problem. So we have a tree. Now you're standing by a tree and there's a 25-foot ladder. Obviously this is not to scale. It's leaning against a tree. What is the length of the piece of rope that goes from the base to the tree and is perpendicular to the ladder? So we're trying to find this, but before we find this, we have to find this little part first, okay? So we're going to find this x first. We're comparing the small triangle with the whole triangle, okay? So here we go. Short leg, okay, where is my information? Short leg is x. The hypotenuse of the small triangle is 5. And then the whole triangle, the short leg, will be 5. And the hypotenuse of the whole triangle is 25. When you cross multiply, you have 25x is equal to 25, so x is equal to 1. So now you're probably like, how did she know that was 1? I'm just trying to make this video a little faster. So this length is 1 right here. And notice I have a little right triangle. This is 20. Oop. Oh wait, this is for the, let's see here. Did I mess this up again? Oh yeah, this is supposed to be a 5, sorry. Just 5. So I have 1 squared plus r squared is equal to 5 squared. I wrote 25 there because I was already thinking of the answer in my head. So r squared is equal to 5 squared minus 1 squared. So r squared is equal to 25 minus 1 is 24. R is equal to the square root of 24, which is equal to the square root of 4 times the square root of 6 to square root of 6. That is our exact answer, but again, we're dealing with distances, so we should find the decimal value, which is 4.9. So that's the length of the rope. So I had to do this in 2 different ways. It's kind of a hard problem, but really play around with these. All right, there's our homework, and there is our Common Core Standard. Have a nice evening.